Hi everyone, my name is Skye Zive.
And I'm Millson.
This demonstration video is to show off our work for the Electrical and Computer Engineering Design course at UCT, run by our fantastic lecturer and course convener, Amit Mishra.
This project involves placing an IMU on an ice buoy in the Antarctic region so we can gather information about the ice and wave dynamics in this extreme remote location.
Ideally, we would like as much of the IMU data as possible, but transmitting data using Iridium is extremely costly as well as vulnerable to packet theft. Therefore, this project will be undertaken with the specific goal of compressing the data as much as possible and encrypting it for transmission safety whilst minimizing power usage.
The design process involved doing extensive research to produce a paper design, followed by simulating the IMU data in MATLAB, and finally doing thorough testing with data from a similar IMU to the one used in the project.
We'll now show you a quick demonstration of our solution.
So just quickly share the screen.
Okay. So we're going to start off by extracting some data from the IMU sensat.
This is just code that we've written, which will periodically write sensat data to a CSV file in the appropriate format. For the sake of this demonstration, we've limited it to only 50 files because we find it can become quite a long process as you increase the size.
Okay, so there we go. If we have a look over here, we see data 50, which is a CSV file. So if we just nano into that file over here, you can see that it's a CSV file, shows the time as well as the sensor readings. So we'll move straight into compression. Okay, so this is a file we've written. Sorry, try that again. Python 3. Okay, so we're going to compress data50.csv, and we'll call that comp.bz2. All right, so you can see it's being compressed. It just shows you the compression ratio, the execution time, and the amount of RAM used. So now if we just nano into that compression file over there, you can see that it's been compressed significantly, but it's not yet legible. First, we're going to move into the encryption stage. So we go into this file over here.
For this, we just got some code, which is a cryptography implementation of encryption. No.
Sorry, just going to encrypt that. Okay, the name of the file to be encrypted is comp.bz2. Okay, so that is encrypted.
You can inspect that file. Okay. And yeah, ideally that should just show that if somebody were to steal these packets, there's no way they could find out what our original data is. And now it is not responding.
And now my computer's dying. What is it?
And now it is responding. We shall continue. Thank you.
All right, now we're going to move into decrypting the file. So Python. Okay, the name of the file to be decrypted is encrypted_comp.bz2. Okay, so as you can see, the file has been decrypted. If we just look at that file itself, it's back to looking like what the original compressed file was like. So it's been decrypted. Now we're just going to quickly decompress. Okay, so it's decompressed. Now, if we have a look at the final output file, same name. All right, so you can see, as before, the original CSV file, it's got everything there, but we also created a file to just check that the contents match the original file. So we're just going to have a look over here and compare final.csv to data50.csv. As you can see, it's a match. But if we had to change something, so for example, let's go into final CSV and just delete this row over here with all the headings. Okay, and Control X, enter. Okay, now if we have to run this file again,
You'll get in time.
okay, and data 50.csv. Okay, so it says that some data was lost in the compression process, and it shows you which differences there were. So thank you very much for watching our demonstration.
I hope you enjoyed watching as much as you enjoyed making it.